Hi, and welcome to another Hopper on 6502 video. This one's from the 65 Arena playlist. And as promised, this is a follow-up using our same Blink example to go through some of the features of the Hopper assembler. So let's first talk about program structure. So you have programs, and if I right-click on this path here, I'll get to the units, and you have units. And this is how it's based on what was in Turbo Pascal, but very similar to like assemblies in C#, for example. So it allows you to encapsulate functionality. If I control backspace, I go back into nice little units like this, so that you can hide the inner workings and organize your code when you're doing larger projects. The name of the unit doubles as a namespace, namespace like C# or Java. So this namespace is qualifying this register. So riot data direction register A. So there's data direction register A. I right-clicked on it to jump there, control backspace to jump, and it's qualified by the namespace, which is the same as the unit. Control backspace, jump back to where I was. Very nice way of navigating your source code. Also, this path up here will take you back to your project file. Your project file is the one with the name program in the beginning of it. It's the main program. And your project is structured by using these user statements. So there's no make files or that sort of thing. Your project is just organized, and the system figures out where stuff is by walking the tree. It's a two-pass assembler, so it doesn't matter what order you define things in. The first pass goes and finds all the definitions. Second pass builds the content that's between the curly braces. And yes, it's very curly brace and semicolon-like. So we've spoken about namespaces. Oh, private and public. So just like Google's Go language, the first character being uppercase means it's a public symbol, and the first character being lowercase means it's a private symbol. So you can hide the internal workings of your unit inside your unit, and they won't be visible or used by mistake from outside the unit. There's also the same concept as friend classes in C++. You can have friend units, so that's a unit that can see the private members of another unit. Methods, they're not really methods. Well, they are, but they don't have arguments and they don't have return types. And in fact, if you try and put one in there and rebuild, you look at the bottom of the screen, there's our error message. And once again, if you can double click on the path, and the cursor will move to where the error was. Actually, if I put the cursor somewhere else, it's more obvious. There we go, jump back. So it's got, error message there saying error at delay 500, no return type in assembly. There you go. Because in assembly, you can do whatever you like with arguments and return values. So there's no point putting them into, it's not a language in that way. Okay, yeah, I've spoken about the navigation. Right-click, control backspace, and you can switch between two different contexts with ctrl+tab, so it can alternate between them with ctrl+tab. All the menu options are up here, all the functions I use, and they all have their shortcut keys next to them. And in Hopper, the debugger and compiler use the same keys as Visual Studio. In this assembler, it only uses these keys anyway. There is no debugger for the assembler. There's an emulator for 6502, but it's not part of this. It's part of Hopper, it's just not part of this IDE. Okay, numeric constants in Hopper are like the C languages. So that's a binary constant, that's a decimal constant, and these are hex constants. You can write constant expressions like that. And you can write more complicated constant expressions. So I could have written this 1 instead as a 1 shifted left by 7 like that. And if I build, that'll build. And for this reason, the regular parentheses always means expressions in a Hopper assembler. If you want to use a if you wanted to reference a 0-page variable like that for some reason, load by reference, or then you have to use these square brackets. And that also is based on the fact of where this architecture came from, and it's C-like, and in C that's how you dereference like a pointer, for example, to get to an address pointer to by a pointer, and that's how you use an array or etc. Just put that back the way it was. Okay, you can do data constants. You can do string constants, which will automatically null terminate. You can do like byte array constants. There's I think 4 value types. There's chars, so you can do like that to load a character. There's bytes, which we've seen, and then there's uints, which are typically used for addresses. For absolute addresses, but you can do expressions with uints in them, and you can also use ints because you might want to do a relative branch, for example. So if you go BNE, you might want to go -5 like that. Yeah, so that would be a uint, even though it's only an 8-bit uint. I mean an int, signed integer, signed 8-bit integer. So those are the types supported. It automatically decides which code to generate, and because I've defined here the CPU as the 65 Uinu, it assumes that it's the 6507, which means it's generating the original MOS instructions. It's not generating the extra instructions that you find in like the 65C02S. You also don't have to tell it how big the ROM is if you say CPU 65 Uino, because it knows you're building for a 4K ROM. For building for other targets, you can tell it how big the ROM is, and it'll assume it's a 6502, and the ROM is usually up at the top of the memory space, so it'll put the org in the Intel hex accordingly. So if you've got a 32K ROM, it'll start at hex 8000, for example, and this 4K ROM starts at hex F000. You can use labels for branches in here, but I'm not a big fan of basically go-tos. I like structured programming, hence these constructs here. But if you do use labels, they're limited to being able to be used in the same method, so you can't jump from one method to another, which would be, it's the main piece of the spaghettiness we're trying to avoid. Loop simply is a jump statement from the last bracket to the beginning, but it supports continue. So continue would jump to the top of the loop, and a break would, if you put a break in there, it would exit the loop. So jump out of the loop. So these are all just jumps. But what it does do behind the scene is it optimizes whether it's using, well, not on the 6502 from MOS. It'll always use a 3-byte jump. But if you're compiling for the 65C02S, it'll optimize and decide whether to use a short branch, 2-byte branch instead of a 3-byte jump. It does a lot of optimization, but I'm going to talk about that in the next video. The if statement, any of the flags can be in there, so that's not overflow not set. So the other ones are like 0 or not 0, or carry set or carry not set. So I use not rather than clear, just because it's consistent. So not view is what that was. Yeah. What else can I say about this? I think that's about it. It's a really pleasant environment to navigate, and you can use all these tools in this tool chain right now. We use the preprocessor, we use the assembler, we use the optimizer, there's a code generator at the end of all that, and then there's a disassembler. And I like working in the GUI like this, but you can use them all from the command line as well. So the disassembler would be 65DASM, and it tells me that I didn't give it enough arguments, so that's what it lists out what all the options are. For the console itself, you type help, it tells you what all the console commands are. And I've got the aliases that are more Linuxy and the aliases that are more like DOSy. So you can choose like whether you like ls or dir. It's up to you. Anyway, let's do 65DASM, and we'll do our blink program and -OG. So if you don't like my syntax and you want to make the syntax, so you don't like double slashes for comments and you want semicolons for comments and you want a $sign in front of your hex, etc., you do that. And so if we have a look at that listing, it's sort of more conventional. Obviously, the comments were generated, they're still with my syntax, but the code itself here is in the more conventional assembly syntax. But if you're switching continuously between a high-level language and assembler, it's kind of nice to work in the curly brace and semicolon language style syntax. Anyway, so yeah, you can use the console to use all these commands, and there are some features to make the format more conventional and not my format. I think that's about it for explaining the features of this tool. I'm going to follow up with a final video on Blink, which is going to explore the optimizer and what it does for you, that we often do this manually ourselves, but what this optimizer does automatically. There is another structured feature. It's got a switch statement, which isn't used in this program. The switch statement, you can switch on any of the registers, so you can, you'd say switch on the A register, and then you've got cases which have got 8-byte constants here, so you can say, which my A command is this case here, B, and you could have a default, and you have to have curly braces everywhere. That's a Hopper thing. So even if it's a single statement, you still have to have a curly brace. And there's no breaks out of case statements, because breaks are to break out of loops, and it was a classic blunder to use the same keyword in C to mean two different things. So we don't do that in Hopper. You just never break out of a case, because how often do you do that? And well, you could actually here, because you could use labels and you could jump to the other label. But I think it's just poor coding style. It's just a personal thing. So this would work, but if you use the X register or the Y register as your case switch, then that allows the assembler to build a jump table, because it can jump on the Y or the X. It can use that for a relative jump. And there's other constraints too to make that work. List of constraints at which point the assembler will decide, okay, I'm going to do a jump table. For example, it would never do it for only 3 cases, because there's it'd be more instructions to get there than if you just did 3 cases. But if you've got a big switch statement with a lot of cases, the jump table is pretty cool, and it does it all by itself. I've got another video in the Retro Shield playlist which talks about the constraints of the switch statement, but I'll probably talk about it again once I do a sample for the 6.5 Areno that includes the switch statement. Anyhow, I think that's enough about the environment. Next video is going to talk about the optimizer.